Right now, above your head, something is screaming through space at 17,500 miles per hour. It's not a satellite. It's not a spacecraft. It's a fragment of a Soviet rocket from 1967. A ghost from the Cold War, still circling, still dangerous, still waiting to collide. In 1958, the United States launched Vanguard 1, a grapefruit-sized satellite that was supposed to orbit Earth for a few weeks. 65 years later, it's still up there, among the oldest pieces of space junk still circling our planet. What began as humanity's greatest triumph has become our most dangerous legacy. Over 25,000 pieces of tracked debris, millions more too small to see, all traveling at speeds that turn a paint fleck into a bullet. The space race didn't just take us to the stars, it turned the sky into a minefield. And now, we're running out of time before that minefield becomes a prison, locking us on Earth forever. October 4th, 1957. Sergei Korolev watches Sputnik 1's radio signal pulse across Soviet receivers, proof that the USSR has beaten America to space. The world celebrates. Moscow erupts in victory. But what Korolev doesn't know, what no one knows, is that this 83-kilogram sphere and its rocket body have just become humanity's first permanent orbital residence, the ancestors of a growing population that will one day threaten everything the space race achieved. Sputnik wasn't just a satellite, it was a declaration of war written in the stars, proof that Soviet rockets could deliver nuclear payloads to any city on Earth. The scientific mission, measuring the ionosphere, testing radio transmission through the upper atmosphere, was inseparable from its military message. And that message fundamentally reshaped U.S. defense policy overnight, triggering a technological arms race that would fill the heavens with metal. But here's what nobody discussed that October night. Sputnik's R-7 rocket upper stage, tumbling uselessly in orbit, had just become Earth's first piece of space junk. The beginning of a legacy we're still paying for today. Within months, America answered. Vanguard 1 launched in March 1958, designed to demonstrate American technological prowess and reassure anxious allies. Today, more than 6 decades later, Vanguard 1 remains in orbit, a 1.5-kilogram time capsule that has outlived its creators, outlived the Cold War itself, a monument to what we now call the original sin of the space age. This is the moment humanity's reach exceeded not just its grasp, but its wisdom. Korolev and his American counterpart, Wernher von Braun, two brilliant minds on opposite sides of the Iron Curtain, both driven by dreams of reaching the stars, but shackled by Cold War pressures. Korolev works in secrecy, his very name classified, racing to prove Soviet superiority. Von Braun, haunted by his Nazi past, sees America's space program as redemption and a chance to realize his childhood visions of cosmic exploration. Neither man considers what they're leaving behind. They designed their missions with no concept of end-of-life disposal. Why would they? Space seemed infinite, a void so vast that a few metal objects could never matter. Their robust constructions, titanium pressure vessels, aluminum alloy structures built to survive the violence of launch and the radiation of orbit, were engineered for durability. And they delivered. Hardware designed to last months has persisted for decades, transforming from triumph to threat. The engineers who built these pioneers express a complicated mix of pride and shock when confronted with their legacy. U.S. Air Force tracking specialists began calling derelict upper stages ghosts, haunting reminders of hardware they'd launched and forgotten, now drifting through the darkness like spectral monuments to ambition. One American engineer later recalled the bittersweet moment of tracking a defunct satellite he'd helped build as it passed overhead decades after launch, realizing his creation had become space junk. The pressure was relentless. Launch first, launch fastest, worry about consequences never. Passivation, the simple act of venting leftover rocket fuel to prevent explosions, was ignored. Why waste time on cleanup when the Soviets might launch tomorrow? By the mid-1960s, Both superpowers had launched hundreds of objects. Each rocket body, each discarded panel, each fleck of paint became a potential bullet traveling at hypersonic speeds, and the realization dawned slowly among tracking specialists. These objects aren't going away. They're accumulating. Every single one is a collision waiting to happen. But the space race was too important, too politically charged to slow down for something as mundane as orbital housekeeping. By the early 1960s, the seeds were planted for what would eventually become over 25,000 catalogued objects larger than 10 centimeters in Earth orbit, a significant fraction originating from these Cold War missions. But the catalogs tell only part of the story. For every tracked object, tens of millions of smaller fragments, paint flecks, metal shards, frozen droplets of coolant, travel at speeds up to 8 kilometers per second. To put that in perspective, at orbital velocities, a paint fleck the size of a grain of sand hits with the force of a hand grenade. A bolt, a fragment of metal no bigger than your thumb, carries the kinetic energy of a car traveling at highway speed. These aren't just objects drifting in space. They're bullets, grenades, and missiles, all circling above us in silent, eternal trajectories. The irony is profound. The same technological achievement we celebrate, the daring leap into space, the engineering brilliance that put humanity among the stars, created a minefield in the sky. Sputnik and Vanguard were proof that we could escape Earth's gravity. What we didn't consider was whether we should leave our fingerprints behind. But abandoned rocket stages were just the beginning. Soon, the Cold War would turn space into something far more dangerous. A battlefield. September 13th, 1985. A US F-15 fighter jet climbs to 38,000 feet above the Pacific Ocean and launches a missile that streaks into space, obliterating the Solwyn P-78-1 satellite in a shower of fragments. It's a demonstration of American military might and the creation of a debris cloud that would endanger spacecraft for decades to come. This is the moment space officially becomes a battlefield, and the battlefield becomes permanent. The ASM-135 test wasn't the first time a nation had deliberately destroyed a satellite. The Soviets had been testing their Indestructible Sputnikov satellite destroyer since the 1960s, perfecting the art of orbital interception. Both superpowers were playing the same deadly game, driven by the unnamed engineers, military strategists, and politicians whose Cold War anxieties drove decisions with catastrophic long-term consequences. But the 1985 American test created something unprecedented. Thousands of trackable fragments scattered across multiple orbits, some persisting for years, crossing the paths of countless other spacecraft. U.S. Air Force tracking specialists referred to derelict upper stages as ghosts, haunting reminders of hardware they'd launched and forgotten, now drifting through the darkness like spectral monuments to ambition. Space warfare had proven itself catastrophically effective and catastrophically permanent. Each ASAT test created thousands of fragments, turning single satellites into clouds of shrapnel. These debris fields spread out along orbital paths, creating permanent hazard zones that exist to this day. But weapons tests were only part of the story. By 2022, over 250 major fragmentation events had been cataloged in Earth orbit. The majority weren't from missiles. They were from explosions of upper stages and failed satellites, Cold War hardware that had been abandoned without a second thought. The culprit was simple: unvented propellant tanks. When a rocket stage completes its burn, residual fuel remains pressurized inside. Over time, thermal cycling in the harsh space environment, swinging from 250 degrees Fahrenheit in sunlight to minus 250 degrees in shadow every 90 minutes, causes these tanks to rupture, creating debris clouds that rival those from deliberate weapons tests. The engineering solution was equally simple: a practice called passivation, venting leftover propellant before abandoning the stage. But declassified U.S. Air Force memos from the 1970s reveal that engineers repeatedly recommended passivation protocols, only to have their concerns overridden by what the documents euphemistically call strategic or operational priorities. Translation: cost and schedule pressures trumped environmental responsibility. The Cold War couldn't wait for safety procedures. Then there was Cosmos 954, the debris event that made headlines for all the wrong reasons. This Soviet satellite, powered by a nuclear reactor designed to run surveillance radar, malfunctioned and began tumbling from orbit. In January 1978, it re-entered. As it descended, engineers in Moscow and monitoring stations across the West watched helplessly. The satellite disintegrated over northern Canada, scattering radioactive debris across hundreds of miles of frozen wilderness. Recovery teams found fragments contaminated with uranium-235 and fission products. The incident cost Canada $14 million in cleanup, only $3 million of which the Soviets eventually paid. Cosmos 954 wasn't just space junk. It was a radioactive reminder that some satellites carried toxic materials, including hydrazine, beryllium, and nuclear fuel, complicating the romantic narrative of the space race with a decidedly darker reality. And then there was the unforgiving physics of it all. The laws of orbital mechanics don't care about politics or intentions. Objects in orbit don't slow down or fall quickly. Debris at certain altitudes can persist for decades, even centuries. Every fragment becomes an eternal hazard. Picture this. You throw a baseball at 60 miles per hour. Now multiply that speed by 290. That's orbital velocity, 17,500 miles per hour. At that speed, there's no such thing as a gentle collision. There's no fender bender in space. Every impact is catastrophic, explosive, final. Scientists began warning about something called Kessler Syndrome, a cascading effect where collisions create more debris, which causes more collisions, exponentially increasing until entire orbital shells become unusable. It's not science fiction, it's physics. And we've created a minefield in the sky where over 25,000 cataloged objects larger than 10 centimeters are now tracked. And that's just what we can see. Hundreds of thousands of smaller fragments, invisible to tracking systems but still deadly at orbital velocities, fill the space around Earth. These weren't accidents of ignorance, they were choices. The same brilliant minds that calculated orbital mechanics and designed systems to survive the vacuum of space understood perfectly well that abandoned hardware wouldn't simply disappear. But the Cold War operated on a different calculus. Winning today mattered more than the orbital environment tomorrow. Every ASAT test, every unpassivated upper stage, every nuclear-powered satellite added another layer to the minefield in the sky. The weapons tests were spectacular and intentional, but they represented only part of the problem. The Cold War ended. The weapons testing stopped, but the ghosts remained, and they're multiplying. Imagine you're a farmer in rural New Zealand in 1972, and you find a perfectly spherical titanium ball in your field, smooth, dense, and clearly not from anywhere on Earth. This is a piece of Cosmos 482, a Soviet spacecraft that was supposed to reach Venus, but instead became one of the most indestructible pieces of space junk ever created. The failed Venus probe, launched in March 1972 with a 495-kilogram titanium descent module designed to survive the crushing pressures and searing heat of another planet's atmosphere, never escaped Earth's gravity. Instead, it became trapped in a decaying orbit, and when fragments finally re-entered, Soviet engineers experienced a moment of horror. Their titanium spheres, built to withstand Venus, survived the inferno of re-entry intact and rained down across the New Zealand countryside. It's the perfect metaphor for the entire Cold War space legacy, built to last forever, whether we wanted it to or not. These weren't cultural artifacts gently preserved in museums. They were cultural meteorites, physical proof that what we launch into space doesn't simply disappear. And Cosmos 482 was just one object among thousands. Today, the cumulative mass of artificial objects in orbit exceeds 9,000 metric tons, with Cold War debris constituting a substantial portion of that cosmic landfill. Most of it concentrates in low Earth orbit between 200 and 2,000 kilometers altitude, clustered in the sun-synchronous and polar orbits that reconnaissance satellites and ASAT tests favored during the Cold War. These are the most valuable pieces of orbital real estate, the zones where Earth observation, weather monitoring, and communication satellites operate, and they're now littered with the indestructible remnants of missions designed without any thought of cleanup. The debris problem is no longer theoretical. In 2009, an active iridium communications satellite collides with defunct Russian military satellite Cosmos 2251, creating over 2,000 new trackable fragments in an instant. It proved that Kessler's nightmare scenario wasn't theoretical, it was already happening. And modern life depends on the satellites threading through this orbital minefield. GPS navigation that guides your car and your phone. Weather forecasting that warns of hurricanes days in advance. Communications networks that carry your video calls across oceans. Internet connectivity that links continents. Financial transactions that move trillions of dollars daily. All of it relies on infrastructure navigating through the debris field created by Korolev's and von Braun's dreams. Today's space operators, satellite companies, NASA mission planners, astronauts on the ISS must navigate this minefield daily. Every launch requires careful trajectory planning to avoid debris. The International Space Station performs collision avoidance maneuvers multiple times per year, firing thrusters to dodge fragments that tracking networks identify among those 25,000-plus cataloged objects. Future missions to Mars, lunar bases, and satellite constellations all face the same gauntlet created by decisions made 60 years ago. Solutions exist: active debris removal, better passivation standards, international coordination, but they face economic and political inertia. Who pays for cleanup? Who's responsible for debris from defunct nations or bankrupt companies? The legacy of Korolev and von Braun's generation, those thousands of cataloged objects, those millions of untrackable fragments, has driven the adoption of United Nations debris mitigation guidelines, requirements for passivating spent rocket stages, and the development of active debris removal technologies that didn't exist a decade ago. But the threat persists. China's 2007 ASAT test created over 3,000 trackable fragments. Russia's 2021 test added 1,500 more. New debris fields rivaling Cold War origins, proving that the lesson still hasn't been fully learned. Without action, some orbital shells could become unusable within decades, potentially trapping humanity on Earth, just as we're developing the technology to become a spacefaring civilization. The ultimate irony, the same ambition that drove us to space, the desire to transcend our earthly limitations, now threatens to imprison us here. The final frontier has become a cage of our own making, a minefield constructed from the very rockets that were supposed to set us free. We began with the triumphant story of the space race, humanity's greatest adventure, our leap into the cosmos. Sputnik's beep heard around the world, Vanguard's defiant orbit, the brilliance of Korolev and von Braun, two visionaries who dared to make the impossible real. But we've discovered the hidden cost of that triumph, a legacy of debris that now holds our future hostage. The same sky we fought to conquer has become a minefield of our own creation, a testament to the hubris of prioritizing ambition over consequence. The ghosts of the Cold War still circle above us, fragments of a race that ended decades ago, but whose consequences will haunt us for centuries. Titanium spheres that survived Venus-rated engineering now fall to Earth. Paint flecks traveling at 17,500 miles per hour, each one a bullet. Rocket bodies that were supposed to last months, now permanent monuments to our short-sightedness, orbiting for lifetimes. We won the space race. Now comes the harder part, taking responsibility for what we left behind. The question is no longer whether we can reach space. It's whether we can clean up our mess before it's too late. Because if we don't, the final frontier won't be the stars. It'll be the prison of debris we built around our own planet, a monument to the moment when humanity's reach exceeded not just its grasp, but its wisdom. What do you think is the solution to the space debris crisis? Should we invest billions in active debris removal, or focus on preventing new debris? And here's the big question. If you could send a message back to the engineers of the space race, knowing what we know now, what would you tell them? Let us know in the comments, and let us know what cosmic mystery or engineering challenge you want us to tackle next. If you enjoyed this story, hit subscribe for more stories where history, technology, and human ambition collide. Thanks for watching.